Okay, so number one, we have that these two sets we said were equal. Why were they equal? Because they had the same elements. Okay, even though you saw some repetition there, it did not matter. They're still equivalent. I'm sorry, they're still equal. Now, the fact that they're equal makes them equivalent, because what's the cardinal number here? 4. What's the cardinal number here? 4. Over here, we had these two sets, so this set has what cardinal number? What's the cardinal number of this set? 4. What's the cardinal number of this set? 4. So those two sets are equivalent, right? So set A is equivalent to set B. But are they equal? No. But set A is not equal to set B. Okay? So if we go back to our notes here, where we said that a set is equal to set B means that set A and set B contains exactly the same elements regardless of the repetition. We symbolize the equality of set A and set B using this statement. We just say A equals B. And you saw that in the one we just did. Okay, now remember our discussion a while ago. So any sets that are equal must also be what? Equivalent. But not all sets that are equivalent are what? Equal. Okay, so we saw that as well. Okay? All right, so let's do this example. Let's do another example. So this will be number 3. So let's suppose in number 3, and the directions will be determine if the sets are A equivalent and B equal. So for each one, you're going to say for letter A, are they equivalent or not? For letter B, are they equal or not? Okay? So remember, equivalent has to do with what word? What idea with equivalent? Cardinal number. Equal has to do with exactly the same elements. Okay? So let's look at number 3. Suppose I had this for number 3. I had these two sets. A equals 1, 7, 5, and 6. B equals 0, 7, 5, 6. So I have those two sets, and let's do letter A. So letter A says, are they equivalent? Are they equivalent? Yeah. Yes, because they have the same cardinal number, right? So for A, you would say equivalent. For B, are they equal or not equal? Are they equal or not equal? They're not equal. Because what's wrong with them? You don't see a 1 in the other, you don't see a 0 in the other, right? So they're not equal. So B is not equal. All right, let's look at 4. So 4, suppose we had this. Suppose we had set of A is the set of x's such that x is an element of the natural number, and x is between 7 and 12. So remember, when it looks like this, you got to remember something from our previous course. So this says that all the x's have to be between 7 and 12, including what number? 7, and not including what number? 12, because there's no equal sign there. And B, let's say, was this. The set of x's such that x is an element of the natural numbers, and 10 is less than x is less than or equal to 15. Okay. So that one, it may help if you do the roster idea for each one. So if you look at set A, what are the elements of set A? If you think about the roster first, so let's do the roster. Let's put it in roster form. It does help sometimes. So what would be in set A? What elements would be in set A? Noah? Where's Noah? Noah. What elements would be in set A? 7. What elements be in set A? Tell me the elements in set A. What would be the members of set A? 7. What else?
Is that 12?
That's a 12.
Yeah, 12. Oh, wait.
8,
12.
9, 10, 11, not including 12.
Not included.
Okay? So your roster would be 7, 8, 9, 10, 11. Okay? In set B, Therese? Where's Therese? Okay, Therese, what would be in B?
11, 12, 13, 14, 15.
Okay, y'all agree with that?
Do you include them? I mean, is he?
No, because there's no equal sign.
Oh.
You gotta remember from a previous course that what we mean by inequality. So there's no equal sign here. If there was an equal sign, then you would include 10. Okay? So in B, you would have 11, 12, 13, 14, 15. So see, it helps to actually list the elements with something like this. Now you can tell me right away, are those two sets equivalent? Who said no? Why did you say no? Because what? More numbers in B. So what's the cardinal number for A? 5. 1, 2, 3, 4, 5. What's the cardinal number for B? 5. Go ahead and say there were more numbers in B. Yeah, okay. It's all right. But you see there are 5 of them, right? 1, 2, 3, 4, 5. Okay? All right. So are they equivalent? Yes. All right, so they are equivalent. Remember, equivalent has to do with cardinal number. They have the same cardinal number. There are 5 elements in A. There are 5 elements in B. Are they equal?
No.
No, the elements are different, so they're not equal. All right, let's do one more. Suppose I had this. Suppose I had the set of x's such that x is a natural number and 12 is less than or equal to x is less than or equal to 20. And b is a set of x's such that x is a natural number and 11 is less than x, that's an x, is less than 21. All right, write that down. Okay, now again, it helps if you list the roster. It helps if you list the roster. So is there anyone I didn't call on that wants to try?
What's that symbol after X?
Yeah, I had to cross it out. I put a 12 here. It should have been an X.
No, in 1-8.
Yeah, that's an X. X, natural number, element of natural number. Was that your question?
Yeah.
Over here?
For the 12.
12 is less than or equal to X, is less than or equal to 20.
Okay.
Okay? All right. So it helps if you put this in roster form, if you list the elements. Is there anyone that has struggled with this previously I want to try now? Huh? This is roster form is listing the elements. And for A, all right. So for A, let's talk about the roster. What are the elements in here? Start with the smallest. 12. Why do I include 12? Because it has the equal sign. What's the next one? 13. All the way to 20. And I'm actually going to list them all. And so B, let's look at B. Someone else want to try B? Now notice that in A, you had you saw the equal signs. In B, you don't see the equal signs, right? So what's the smallest natural number that's within 11 and 21? Yes,
12.
12. All right, so you'd say 12. What's the next one? 13, all the way to what?
20.
All the way to 20, good. Okay? So even though it said building notation, they looked different, what do you notice about the two sets? Are they equal? Yes. Are they equivalent? Are they equivalent? Well, if they're equal, they have to be what? Equivalent. Remember, equivalent has to do with cardinal numbers. How many? What's a cardinal number of set A? 9. What's a cardinal number of set B? 9. All right. So they're both equal in what? Equivalent. So you would say for part A, you would say equivalent, and for part B, you would say equal. Okay. All right. Okay. Now let's talk about the next. It's like 2 minutes for the next objective because that's easy. We already talked about that idea. You remember the set of natural numbers? Is that a infinite set?
Yeah.
Why is that an infinite set? It doesn't end. You can't list them physically, right? There are too many of them to list. It's an infinite number of them. What's the opposite of infinite? Finite. The opposite of infinite is finite. So I'm going to ask you this. Is this set A that I'm pointing to, is that a finite set or an infinite set? Finite. You can count how many there are. How many are there? 9. And B is also what? Finite. So a set, let's look at objective 8. So a set is said to be finite. A set is said to be finite if it contains no elements. If it contains no elements, or the number of elements in the set is a natural number. Okay, so let me talk about what that means. So you see that second one, the number of elements in the set is a natural number. What are your natural numbers? 1, 2, 3, and so on, right? So when I looked at set A a while ago and it said that there were 9 elements, then 9 is what kind of number? A natural number. All right. So if you come up with a natural number, then it would be a finite set. Okay. Let's look at the first one. The idea that no elements should confuse you. So I'm going to ask you this. And it's after you see this, you're going to understand it. So this is objective 8. All right, number 1, suppose I had this set. 1, 2, 3, 4. Is that a finite or infinite set? Finite. So it's finite because there are how many elements? 4 elements. Okay, what about this one? Number 2. A set can either be finite or infinite. So either that set is a finite set or it's an infinite set. It's finite because there are what? No elements. So remember in our definition a while ago we said a set is said to be finite if it contains no elements or it contains a finite number of elements. It has a natural number as its number. So no elements would be what kind of set? What kind of set is this? No, it's a finite set, but it's also earlier, which one? The empty set. So the empty set is what kind of set? Finite set. The empty set is a finite set. So let me go ahead and write that down. The empty set. So this is a finite set. It has no elements. All right, so the empty set is a finite set. Okay? All right, and then number 3, suppose we had this. So question would be, is this finite or infinite? Suppose we had B is the set of x's such that x is an actual number and x is greater than 10. So is that a finite set or an infinite set? Infinite. Because if you look at the roster form, if you look at it in terms of roster, so if you look at it in terms of roster, what will be the smallest natural number that will be in here? 11. So 11 was the next one. 12, 13, and then the ellipsis, right? So that would indicate there's how many in there? An infinite number. So that's an infinite set. That's an infinite set. Okay? All right. So let me give you that other worksheet to get you started on. And then again, help each other with this.